Now we are going to focus on SRP table, standard reduction potential table, and the strength of oxidizing and reducing agent. Okay, when we look at the standard reduction potential table, the equation is the half reaction is right in terms of reduction. Okay, so on the left hand side, it is oxidizing agent. The species on the right hand side are the reducing agent. Okay, so if the standard potential is higher, means it is stronger oxidizing agent. Okay, now I will compare both Fe2 plus and magnesium 2 plus. Okay, the question is, which is a stronger oxidizing agent? Okay, why I purposely choose these two examples? Because I want you to understand what is the meaning of more positive or larger value. Okay, between negative 0.44 and negative 2.36. Okay, in terms of mathematics, we would say that negative 0.44 is more positive. Okay, so the more positive means that it will become stronger oxidizing agent and it will act as cathode. Okay, so the answer will be Fe2 plus is a stronger oxidizing agent. Okay, next one. Write half cell equation at anode and cathode just by comparing the value of standard reduction potential. Okay, now this time I give positive value. Okay, so if positive value, we are going to choose more positive and larger. Okay, so more positive and larger means that 1.82 is larger than 1.36. So the cobalt ion will become the cathode. Okay, so cobalt becomes cathode and anode will be chlorine. Okay, so for chlorine, remember it is anode is oxidation, so it's negative 2 becomes 0. So oxidation number increase, so it is anode. Okay, so which is oxidizing agent? Which is reducing agent? Okay, so we look at, okay, one is we look at the value 1.82 and 1.36. Okay, the higher one would be stronger oxidizing agent. The lower one will be stronger reducing agent. Okay, or else, as you have learned before, in anode, okay, it reduces the species, so it is reducing agent. At cathode, it oxidizes other species, the other species, so it is the oxidizing agent. Okay, so you can use both ways to determine whether it is reducing agent or oxidizing agent in a galvanic cell. Okay, so that's all for this part. Oh, sorry, there's one more. Okay, so if you are given a table like this, you must know that, okay, look at the equation, it is reduction. Okay, if it is reduction, then you must know that on the left hand side it is oxidizing agent. On the left hand side is oxidizing agent. On the right hand side it is reducing agent. Okay, so the question asks for arrange the strength of oxidizing agent. Okay, oxidizing agent, we are looking for standard reduction potential more positive. Okay, according to ascending order. Okay, so that we know that this one has the highest, this one has the lowest. Okay, so we arrange accordingly. And remember, when you want to write the oxidizing agent or reducing agent, remember to write the phase. You can use the symbol or you can just use comma. Okay, second question. Which species of this species can oxidize chloride ion to chlorine gas? Okay, so we need to look at the value. Okay, the standard reduction potential for chlorine is positive 1.36. Okay, so how to oxidize chloride ion to chlorine oxygen? This means that chlorine is anode. So what is your cathode? Your cathode must have greater value than the anode. So among three values, positive 1.50 is the largest. Negative 1.3 cannot oxidize. So the answer would be beryllium 3 plus. Okay, so remember, I want to highlight again, that is, when you are giving oxidizing or reducing agent, remember to write the phase. Okay, so that's all for this part.